Uh, okay, so let's start. So in IT, so today we're going to do chapter 9 and chapter 13 R. We are very short chapters. Let me open one. You go for a job interview and we ask you, what do you know about ARP? It's something simple. I need to clear some of my stuff. CLS, also clear. CLS, yeah. ARP. So see, if I type ARP, what do you see? You see a IP and you see a MAC address. IP, MAC address. So ARP is what? I know the destination IP address, but I don't know the destination MAC address. So for my packet to travel from my PC to, let's say I want to open cisco.com, I know the IP address, or I can type cisco.com and I press enter. It's turning. So you see, why it's busy turning, it means it's busy checking the MAC address of the remote. Is checking the IP address of the remote PC of the server. It's busy checking. When you find it, then you can see that the pages, the web page are starting displaying. You see. So ARP is what? ARP is I know the destination MAC address. I know the destination IP address, but I don't know the MAC address. How things will be done. I can come here, I can type also ARP, ARP. So also, if you go in your NetAcad and you see some short videos about ARP, let me type Cisco. If not, we begin to bring a lot of ARP stuff. Yeah. Yeah. It's ARP. You have some short videos explaining ARP. So nowadays, with internet, you can get any answer. You just need to Google it or to YouTube it. So ARP is, I know the destination, IP, but I don't know the MAC address. How will I get that MAC address? That is what we call it ARP. So if I check by my side here, I know my destination IP. You see. So if you tap ARP-A, it will show you a table with destination IP and MAC address. So that if next time you want to reach that destination, automatically it will populate and it will store in the cache. Let's quickly start. My hard drive is full. I need to clear some stuff. Address resolution. Address resolution. So MAC address and IP. So anytime you send the data, we have two parts. The MAC address that will be managed by the switch, and the IP address that will be managed by the router. Layer 2, MAC address by the switch. Layer 3, that will be managed by the router. So if The PC, you see 10.1/24, 10.11/24. If they belong to the same network, mhm, you see, layer 2 addresses are used to deliver frame from one network interface card to another network interface card on the same network. If a destination IP is on the same network, the destination MAC address will be that at the device. What does it mean? PC1, this is the IP address. You want to communicate with PC2, we are in the same network. So for that, it will be easy. From here, from PCA, source MAC address is all A's. Destination will be all 5. If we belong to the same network, they know each other because we belong to the same network. Destination for IP addresses, source IP 10.10, destination 10.11. So it's easy if you belong to the same network. Now, if you're not in the same network, it's a bit different. So read first, then I'm going to explain to you. So now CPC1 want to communicate with PC2. We are no longer in the same network. You see, this one is 192.168.10.0. The remote one is 10.11. You see, very different. So if PC1 want to communicate with PC2, the destination MAC address, the IP addresses will never change. Source IP 10.10. Okay, here you see 10. V 10 network, so 10.10. And the remote, I know also because I want to communicate. It's like I want to dial your number 1.0. So destination, okay, 1.0, so it will be 1.10. So this one will never change when the packet is traveling. But now, what about the MAC address part? The MAC address, the source MAC address will be for PCA. Now the destination MAC address will not be for PC2 because it's too far, I don't know. So the destination will be the MAC address of this interface of a router because at least we are in the same network. So this one will be put here, you see. Then when the packet will reach the router 1, it needs to travel to go to PC2. So when the packet leaves router 1 to go to router 2, the source MAC address will be for router 1, destination will be for router 2. When the packet arrives at router 2 and almost reaching PC2, the source MAC address will be the interface of router 2 with interface G000, and the destination MAC address will be here. Then your packet will be delivered. You see? It seems strange, but this is the way this is the way it is. It seems strange. 1 second, let me see. Yeah. So this one, they ask a lot for job interview to check if a student did study CCNA, because there are some people, they stay home, they buy the exam online, they copy paste, and hey, I have my CCNA. Everyone knows how people they get this stuff. Now they test you, they give you question, the job interview, some questions. So this is how when a packet is traveling, how it's going to populate source IP and MAC. IP address will never change. Source IP destination, it will never change. It's fixed. But the MAC address will be changed. So read again, check, and we continue. Okay, this is the way it is when a packet is traveling. That's why sometimes you see when you type cisco.com, you see the browser is turning. It means when it's traveling, is fixing the MAC address. When it comes here, it's fixing. When it reaches the destination, then you can see your page showing up because of these MAC addresses. So you can also read this one, then I'll explain. Yeah, so ARPA is the way to find, I know the remote network, the remote IP, but I don't know the MAC address. If it belongs to the same network, it's easy. But if in the remote network, then I need to go step by step to um, to to fill up the MAC address, the destination. So when it's found, it's going to get a table, and we call it MAC address table. Okay, the function of of ARP. Okay. Okay, and anyway, if you understood what we explained and you have also a video, it's exactly the same thing. You have also a video. So sometimes it's a bit confusing here. So show IP ARP, display the ARP table on a Cisco router, ARP space dash A, display ARP in the Windows. Okay, okay, so to keep it simple, ARP is what? I know the destination IP address, but I don't know the MAC address to complete my packet. So when the packet will leave my PC to go to the router, my source MAC will be my PC, and the destination MAC will be interface of the router, and step by step until it goes. That's all. And anytime it find that, it's going to put in a table. Yeah, that's all, nothing else. Anything else, sometimes it's confusing. After you read, yeah. So that's all for ARPA. If you
Sorry,
know,
sir. One question,
yes,
Fabian here.
yes,
You said the source, the MAC address and the source destination, they are changing, except that the IP will remain the same. Are these two,
yes.
they are changing based on what? I know you send the package,
Mm-hmm.
the PC and PCS to communicate in the same network, but now these two are changing based on what?
Yeah. So you see, let me go back here because the main thing of ARP is here. If you're not in the same network, so it's like I want to PC1 want to communicate with PC2. I know the IP address of PC2, but for my packet to leave me to go, I need I need the IP and the MAC. I know the IP of PC2, but I don't know the MAC address of PC2 because it's inside somewhere in the PC. So for your packets to travel, when on PC1, your PC knows source IP, it's me here, .10, and I know the remote because I want to join him. For example, I type scalabrini.org and I press enter. So scalabrini.org is the IP address. It will be changed by DNS, and the name scalabrini.org will be changed to a IP. So I know the destination IP. But for the packet to leave, your PC to go, when you press ping to ask for a request, I know the source, it's me. I know the destination, I know. Now, my packet need this section to be filled. Source MAC address, it's me, but I don't know the remote one. So to go step by step, if I grab a packet between PC1 and the router, source MAC address will be for the PC, is it all A's? And the destination MAC address will be the MAC address of interface of R1 G000. If I know that, then my packet can leave and it reach here. You see, because without all this information, your packet cannot leave. Like you want to send an envelope to someone, but there is no address. The post office cannot help you. I need, so address, all these four should be there. So when it reach router one still need to transfer your stuff. Still no one knows here. So your packets, when it leaves here to go to router 2, source IP destination will never change because traveling. The problem is the MAC. So the router will say, okay, you know what? Take my MAC of triple C, 6C, double C, double C, double C as source, and take the MAC of this guy, G001 or R2 DDDD as destination. Then your packet will go, you see. When it reach router 2, it still need to reach the destination. But we have a problem with source and MAC. The router will say, okay, you know what, packet, take my MAC, what is that? Is it CC? Yeah, CC as source. And now, because we are in the same network, I know for PC2 it's 5555. Then the packet will reach there. So sometimes when you type something, for example, let's say Pretoria news.co.za, you press enter, and you press enter. You see your browser is turning. Okay, see it's a cross, it's turning. You see it's busy changing all these MAC address quickly. When everything is found, now it's going to show up here. It's going to display. It's quick now. But for us, network engineer, we should know when a packet leaves, you want to send something to Matadi, for example. So DHL will say, okay, I'm going to leave Fabian's home to go to DHL in Cape Town. This is the first steps. Source, destination. Now, DHL will say, okay, I know where to send it. I know that it's Matadi. But what are the different steps? So from Cape Town DHL, it will go to Johannesburg DHL, the big office. And from there, it will go to DRC big office, maybe to Kinshasa big office until reaching. You see. So all these steps, I know that the destination, the destination town, but all these steps, all these different steps, it will leave where to reach there, leave where to reach there. So the MAC address will be populated by that. Yeah. That's all, nothing else. So this chapter is there because sometimes we have some issues, and these issues are not here for now for CCNA. The big issues, and we troubleshoot at the CCNP level. So we go step by step. Like IT essential, we don't know what we're doing step by step. So for now, when a packet leaves, these are the steps. It reach here, it reach here. So what's happening in the packet? That's all. That's all for. If maybe you want more info, you can come to these guys. Because me, for example, at university, I was comparing 3 books. Book A, I read with definition. Read book 2, book 3. Then I make a summary. You see. So here you can see some. You see, a 12-minute ARP. ARP. This one is 10 minutes or 4 minutes. In 4 minutes. This one is 6 minutes. Let me play this one and see. Sorry, my laptop is almost full. It's slow now. Okay, anyway, you could check that a bit later. If you want, I will send you all these short videos so that you can compare 3 or 4 to understand more. But it's not a big deal, and we don't do that a lot. It's just to understand when and how your packet is traveling, what are the information in IP and MAC, that's all.
Sorry, Mr. Max. When the package is sending from the PC1 to the PC2, it goes automatically, or there's something need also to fix manually?
No, it goes automatically. Let me show you. Because your packet will leave your PC to go to a router, and the router also will forward to another router until it reaches destination. But when your PC leaves, when your packet leaves your PC to go to a router, what will be the information here? The information are IP address will never change, .10 source, 1.10 destination will never change. What will change is the MAC address. My MAC address, then my router interface MAC address. You see, if my packet knows that, then it can go. If one is missing, your packet cannot leave your PC. Why? Because, 1 second. Why? Because all these 4 should be there. This is how it is. It's like you want to travel, you have a flight ticket, but you don't have a visa. You need a visa plus a flight ticket, you see. So always, so when it reaches the router also needs to forward. IPs will never change, but the MAC address is a problem. So the router will say, okay, you know what, take my MAC as source and the other one as destination. Then the packet could travel. When it reaches router 2, the packet knows the destination IP, but it doesn't know the MAC addresses. The router will say, okay, you know what, take my G000 MAC address as your source. And now, because PC2 and R2 they belong to the same network, I know now the remote, then it will travel to reach them. Yeah, so nobody don't spend too much time on that. I'll send you 2 or 3 short videos and you can compare. Yeah, this is what you call address resolution protocol. I know the destination, but I don't know the MAC address. How am I going to find this MAC address? I go step by step, step by step, step by step. I think we did that in CCNA1. At the beginning, there is a chapter for that, but I forgot which one. I'll try to find it for you also. Yeah, so don't spend too much time on that. It's why? Because it's something we don't do a lot on. It's just to understand something. Okay, so read. Let me change the colors to put in red. Where is it here? I'm going to remove that and put this color. Yeah, that's the most important to know from here. That one. So you can read the yeah, you can read all these slides. It's fine. It's something we don't do a lot, and we just see once and then finished. Okay, so you get time to. I'll send you some short videos. It's a short, short chapter, very nothing special. The other one will be ICMP. ICMP. If you want to test connectivity, we use ping and trace routes, and it's just to test connectivity. What does it mean? ICMP. So in this chapter, the most used is ping and trace route for testing, to test network connectivity. What does it mean? You want to go to Pretoria, you take the bus. You're going to stop, you get some stops. So let's say, for example, you're traveling, you're using the bus. Normally, you leave here at 8 a.m. You should reach destination 11 a.m. At 11 a.m., you call the destination. Is the bus there? They say, no, the bus didn't arrive. How are you going to find where is the bus? Then you check all the steps. You take your map. Okay. The bus should leave Cape Town CBD and go to Belleville stop. From Belleville stop, it goes to, let's say, Paarl stops. From Paarl, it go to Worcester, something like that. See. So now you're going to call each stop. Is the bus was there and left? You say, yes, the bus was here and left. You call the second stop. Did you see the bus? Yes, it left until you reach maybe, let's say, Bethlehem, let's say somewhere in Free State. Did you see the bus? Yes, the bus is still here. We don't have petrol anymore, and we don't have petrol here in the station. So the bus is here, you see? So this way of checking, did you see the bus? Did you see the bus at each stop? We call it trace route. You trace the route. You trace the route. The protocol, the agreement to do such thing is called ICMP. the program to test all these things. We call it ICMP. So sometimes when you read the complicated, we make it too complicated. In a nutshell, ICMP is a program to manage the test, the testing connectivity tools. Sometimes you can get some error message like destination unreachable or protocol unreachable or something like that. But we'll do some testing. We'll do some packet tracer for that also. Okay, this one also I'll explain in CCNA2. We still have a long time to. Okay, IPv6 for now, you can leave it because we don't use a lot. I did my CCNA 2005. We say, oh, IPv6 is coming soon. We're going to use IPv6 21 year, still nothing. Yeah, so it's good to have an idea. It's going to replace IPv4, no more IPv4, but we're still using. So yeah, ping and trace we wrote test. This one is very important for networking. So ping is like I'm dialing your number. If it rings, it means at least I'm getting something. You can either pick up the phone or you can go to voicemail. So ping is to test the connectivity. The other one I'm going to share.
Sorry, Mr. Max.
Yes.
Sorry, Mr. Max. Fabian here. Tell me now, in a real life, after the cabling, putting the switches or in place, the routers. So how do we test the connectivity in a real life? This one you're talking about the ping in the packet tracer. So do we do the same in a real life, like when we're on site? After
Yes. Yes. For example, you have yeah, for example, you have you're in Cape Town, and we say, you want to create a new company, set up the network for Cape Town office to communicate with Pretoria office. When you finish your setup, you need to check if it works. So you take a PC from Cape Town to ping, ping to check if you can reach. Sorry, I'm going to connect my charger. One sec. That's in real life we use a lot. For example, something is not working. People can say, we cannot, so we want to send a file to Pretoria, but it's still failing. We are getting a message, destination unreachable. So PCA is here. So let's check the IP. You see, we can close it. We go to other PC, PCC. Let me check the IP. Is 30.2. I'm going to copy it. It's like the cell phone number for PCC. And from PCA, I'm going to dial. I'm going to use my phone to dial, and we call it ping. Let me say clear or CLS. Okay, this one is okay. So I type ping. I'm dialing the number ping. The PCC IP address. I press enter. You see, even if you tap the ping, it's still doing the ARP. The packet is leaving me to go there. What will be? You see, time out. Time out. It means it didn't reach yet. Let's wait and see. You see, I send packet. I send. You see, I sent 4 packets. I didn't receive anything back. It means I lost 4. It means PCA cannot connect with PC. See, base 2 cannot connect. So we need to find what's the problem. We're going to use trace route. So if you're using Windows, it's trace RT. But if you're using the router, it's trace route, the full word. I paste, I press enter. I'm tracing the route to check all the stops. You see, I have a problem somewhere. So it's trying again. The packet is trying to leave my PC to go to a router. Okay, it means I have a problem. So let me go to my router here. I did something this morning. I hope, yeah, this morning I did configure IP, but it was IPv6 only. Okay, so let's go to the router and see, enable, show IP. You see, we need ping and trace route to fix the problem now. You see, show IP interface brief, because we should communicate. Okay, on this is 100.1 for the interface. So which one is where? So you see, I'm going to edit the option, preference, always show port label. So here is G0000, okay. So this is IP of G000. I take it, I close. I open this PC. What's the IP? So you see already, I have address mismatch. How come here is 162.10.10 and that side is 100? You see, it's already, there is a problem here. I need to fix. This is how we troubleshoot. We fix conft. I go to that IP interface G000. And if I want to remove, I tap what? No. For Saturday, if you configure interface, before you leave, you must remove all the addresses. If you don't remove, next session, we want to use a router or a switch, people are confused. It doesn't work. You must clear everything first. No IP address. Sorry. No IP, question mark, you see, address. You see, no IP address. You see, and you save, do, copy, run, start, and show IP interface brief. You see now on that interface, I remove the IP. So anytime you use a real router, please, before you go home, before we close the session, clear everything, remove everything to make clean. So that next time when you come, everything's clean. We don't need to troubleshoot. Now we're going to configure the real IP. Conft interface G000 IP address 192.168.10.1, not 100, you see. 255.255.255.0. No shut. Do copy, run start. Then I go to my PC again. To check if I can still ping the other PCC. You see, now it works. So now we're going to explain these things. Ping, it means I'm dialing from PCA PCA is in Cape Town, and I want to see if I can communicate with someone in our office in Pretoria, because maybe we can upload some stuff there. We can download from stuff from the server to our office or whatever. So PCA and PCC, we can now communicate. So now what does it mean, all these things? Ping, remote address, it means I want to dial your number to make sure that we can communicate. See, pinging, I'm sending some packets. I'll send 4 packets. I received 3, there is 1 lost. So it means the communication is not quite good. I'm trying again. You see, so I sent 4 packets and 4 returned to me. It means the destination did receive and reply to me. I didn't lose any packet, 0% loss. So the first packet, when I sent, I get a reply for him. He say hello, he say hello. Okay. I send again, hello, are you there? He's replying, yes, I'm there. And I again, are you sure you're there? We can communicate? Yes. You see, anytime I send a packet, I get a reply from the destination. It means we can communicate. So time to leave is how many router you're going to reach before destination. Anytime I go to a router, it can be -1, -1, -1. It depends. In real life, here is a packet tracer. This is an example of thing. You see, it means we can communicate. Now let us use trace route. Trace route. Trace. I press enter. You see, when my packet leaves my router, my PC, the first step number 1, it goes to my router interface, G000. Then it will go to router 2 interface. Then it will reach PCC. So the trace route or trace routes will show all the steps and the stops until it reach the destination. So we use that a lot to fix issues. Why it's not working? Why we cannot communicate? From now on, ping and trace route will be our friends. Will be our friends. There is also another comment on the router we call CDP. Show CDP neighbors. There is even Fabien here. Show CDP neighbors, it means I'm on R1. What are the devices that are directly connected to me? So R1, what is R1? R1 is here. Let's go to R2. What's the name of R2? Enable. Show run. So here we didn't communicate. We didn't set up a name. Let's go to the switch. The switch name is Fabien, you see. So that Fabien guy, if I type show CDP neighbor, you can see that there is a device called Fabien that is connected to me. And you see it's a switch. And this is it's the iPhone 10, iPhone 20, the number is here. And on router 1, another router is connected via this interface. R, it means it's a router, which is. So this is 3 new commands you should know: ping, trace route, and show CDP neighbors. So remember, on Saturday, we're going to try that. We're going to connect 2 routers, even switch and what, and we're going to type show CDP neighbors to see if it's going to know. Let me add another switch on the router. I'm going to add a switch and put a switch here. I'll connect that switch to the router. And I'm going to call that switch. Okay, it's loading the Windows 10 or Windows 11. So for a switch or a router, we call it iOS, Internet Working Operating System. Enable, conft. I'm going to call it host name. Let's say Pretoria. And I save. Copy run. You see. Then I close it. I go to my same router. I'm going to tap again, show CDP neighbors. I press enter. Okay, so it needs a bit of time for them to talk together. You need a bit of time for them to, you see it read. I didn't configure G001, that interface. You see, this is how we troubleshoot why these two cannot communicate. You see, G001 interface not activated. So I go there, conft interface G001. Let me say no shut, no shut. Do copy run start and show CDP neighbors. You see now I can see my switch that is called Pretoria. So all these tools we give us is to fix issues. A network engineer, we install stuff, we make sure they work. If it doesn't work, we need to fix. So we have some tools. Show CDP neighbors to see I'm R1. What are all the devices that are directly connected to myself and to me? I have a switch called Fabien, see S switch. I have Pretoria, it's also a switch, and the model via which interface, see, which interface on the router, and on the switch is this. See. So this is how, so step by step, we'll reach them. We'll do some labs and yeah, okay, I think that's all for today. Yeah? Ping and trace routes, yeah, anything else is you can read and practice, but this is, you can ping anything you want to. So for example, if you're in the router and you want to reach the other PC 30.2 ECC, I'm here, I'm in the router. I want to ping PCC 192.168.30.2. I press enter. You see, if you see exclamation mark, it means it works well. It's success. You see. Let me add another PC without a IP address here. Without an IP address, I put like that. No. So I need an IP address. I wanted to fix something, but let me see. Okay, let me add. So here, so I'm going to make a mistake on 30.1. I'll put 30.2 here. I put here. I can put 10. And normally here should be 30.1. I'll put 30. Let's say 20. 30.20. So I'm going from the router, try to ping this guy. From the router, 30.30. I press enter. You see. I cannot reach this guy because there is something wrong on his configuration. Now I see dot dot. If you see dot dot, it's wrong. See here, exclamation mark, success rate 100%, 100% success. Success 0%. It means there is something wrong. From me, the router cannot communicate with that PC. I need to go fix. Or I can also do trace route. Trace route 192.168.30.30. I press enter. See, the packet will leave me to go to router to interface. This is router to interface. This interface, see, serial 010. I'm here. The packet will leave me and reach this interface of the router. Now from here, the router should send to a guy. But now what's happening? The packet is stuck here. You see, so from this bus stop, there is no traffic anymore. You see, it means I need to go to this router to double check what's happening. Then you go to that bus stop to find out what's happening. You see. So if I come here and I ping the PC, I'm in router 2. Let me try if I can ping the guy myself. Ping. And let me check the correct IP. Okay, it was 30.10. Okay, let me put 30.30 to keep it the same. So I'm in router 2. Let me try to ping this guy, 30.30. 192.168.30.30. Press enter. So from me, the router, I can ping the guy. You see. But now the other router cannot ping it. Let's go back again. It's still looking. I have to break that. Let me close it. It will still continue. I have to break this. It's Control Z. So it still continue until it says wrong. But this one will go for how many stops? I have to break. Okay, let's check if this guy is there now. router, 28, 29, then 30, then you see. So it didn't reach with destination. So let's try to ping again. Still not. Let's fix the default gateway. 30.1. Let's try again. See, now it works. If I tap now the trace route, you see now it works. So IT, sometimes we are here, we are there to build, but also to fix issues. So you see. So the demo I did is to ping from the router or trace route. If you ping in successful, it will be exclamation mark. If it's unsuccessful, it exclamation marks. What does it mean? It means successful 100%. So with PC, I'm R1, with PC will go to router 2, and router 2 will automatically send to his PC. So from now on, we're going to use with 3 tools a lot. A lot. Ping and trace route. Okay, guys, that's all for this chapter. Huh? Really nothing. So I can say that in a nutshell, we are done. We did at least 80%. Not everything, but what you should know. Yeah, it's what you have. So from now, we don't have any session anymore. Take this time to do your revisions. Anytime you have questions, I'm around. You can feel free to ask questions in WhatsApp group or ask my. So for your final exam, we said it starts from 4th of, in the 3 weeks time, you have 5 days. You can do any time between these 5 days, and you have 3 attempts. 3 attempts. Any questions? So congratulations, guys. But you made it. I'm very proud of you guys. We finished with first part.
Mr. Matthew, for me, I have a lot of questions, but on Saturday, I think I'll ask a few questions. One that I want to know, if I'm on the router, let's say the one I'm using at home, if I want to know to trace route, will that be possible to see, or DCP,
Yeah.
is it DCP neighbors that comment to see? Will I be able to see who's being connected?
Yeah, yeah. And from home, you cannot, because it's only one router. It's a Wi-Fi router. You don't have another router connected to you directly. You see, you don't have another switch directly connected to you. But on Saturday, when we connect 2 physical routers, we take one router, we're going to maybe to connect 2 switches to a router. Then from the router, you can tap show CDP. So even let's go to a switch and check if it can also do that. This switch, let's use this switch. Enable, show show CDP neighbors. You see? So on from this switch, I have only one guy that is directly connected to me, R1. So if you don't have any other switch or router connecting to you, it won't display anything. But you can try, we never know. In IT, me, I say nothing is possible. Just try. Just try. See, from example, if I tap cisco.com, if I tap cisco.com, I press enter, you see it's turning until now suddenly you see. So while it's busy turning, it's busy doing the resolution, the MAC address from my PC to my router, the router to my ISP, it's quick. So it turn when all good, then it shows. It shows up. There is no error message. Now from my PC, let me check if I can ping Cisco. Normally it should be successful because I can see the web page, ping cisco.com. I press enter. You see, the packet is leaving my PC. All good. This is zero loss. Now let me trace the route. Trace, sorry, trace, what is it here? Trace cisco.com. You see? So the packet is leaving my PC to go to my router, my Wi-Fi router, who is here. Then step by step is going to resolve some stuff in the background. Sometimes it does that, but it's good to be patient. Then you try again because of the ARP. You try to do some resolution. You see now, it's going to my ISP, RAIN. I'm using RAIN. The packet has reached my ISP. Now my ISP will send to someone else until it will reach. Yeah, it can take some time, but at least yeah, it's something we'll do also on Saturday. Anything you want to do, you have any questions, Saturdays are there. Any other questions, guys? Okay, no questions. So yeah, we are done. Anytime you have question, feel free to contact me or in the WhatsApp group, or I'll be there to contact you, to help you. So we meet on Saturday. Then please bring your own extension, your own charger. If you have laptops, bring them. We're going to work in groups. Eat well, drink well, cover yourself properly because the aircon will be still there. I hope you have heater, but who knows?
Max, please, can you send us this thing, the recording, if you can, so that we can work on that one? Some of us, we want to go back. I mean,
Okay, tomorrow morning, no problem. So remind me tomorrow morning, then I'll send to you. Yeah.
Please, thank you.
Okay, no problem. And also these short videos, you can go to YouTube, you tap ARP Cisco, and we have some short videos explaining if you want to. We also have ping and trace routes. This guy is very good. So I learned a lot from him, from my Cisco. I learned a lot from his videos. So at the end of the day, you must know what you do. You see. So you can ping, trace route. You tap, press enter. You see, you also have some short videos explaining. We do some demo, traceroute explain, traceroute explain, ping. So always a network engineer should do some research. Always. Then combine all of them and make your own findings, your own summary. You see here, we are trying to go, you see. So compare, always do some research, ping comment, trace route. You see. Okay, that's all for today. So thank you very much, guys. I'm still around, even if we don't have sessions for 2 weeks. And I wish you all the best. You'll make it, guys.